talk about homework 5, which is has been posted online, and it it's a challenge. So I've assigned this before, and it's an evolving project or activity, and I think it's a good example of computational statistics. So again, computational statistics are part of it is answering questions that are statistical or about probability in nature, but may be difficult to answer from an analytic perspective. Okay, so here in this game, or in this assignment, you're going to simulate a game of Monopoly. Okay, but we're only going to simulate the board movement. So Monopoly is this board game, and I imagine many of you have played it. But if you have not played it, you can watch videos, or you can play it with a friend and get a feel for it. And in the game, you move around this game board. You're trying to purchase properties and charge rent, and you're trying to bankrupt the other players, take everybody else's money, so you're the only one with money at the end of the game, which is kind of messed up that we're having our 6-year-old kids play this. But anyway, it could be a fun game, and anyway, you basically start at go, but you just move around the board in a circle. And as far as our simulation goes, we're only simulating board movement. We're not going to simulate keeping track of money or properties or any of that stuff. That would make the assignment way too complicated. So here we're just keeping track of board movement. Okay? Now, if there were no special rules, the board movement would be would be uniform in nature. Okay? You just roll the dice, you move that many spaces, and as far as keeping track, you would just keep a tally of where people have landed. And if there were no special rules, the probabilities of where people land would be uniform. However, there are rules that change the probabilities of where people will land. And so this assignment wants to keep track of which spots are more likely to be landed upon and which ones are less likely to be landed upon. Okay? And so let me cover some of these rules, and I'll talk about implementing this solution. And so again, this is a good computational statistics problem because technically we could come up with kind of some mathematical equations and forms of all of these rules that affect board movement. But I would say it would probably get rather complicated really quickly as far as how it affects these things. And so in this case, I think it's easier. You might argue that it wasn't easier, but I think it would be easier to build a simulation and run this thousands and thousands of times. And after running the simulation so many times, we get an idea of which spots have been landed on more and which ones have been landed on less. This is a problem that has been studied already in the past, and so you can go online and look up Monopoly board probabilities, and people will have write things. And there's even a book on like everything I learned about business I learned from Monopoly, which now I question your business school skills, but there have been a lot of books written about playing the game of Monopoly here. Okay, so as far as board movement goes, you'll be moving around. There's this one spot that says go to jail. As soon as you land, or quote land on this, you immediately go to jail. So in this case, the way I've interpreted the rules is that go to jail will never accumulate a tally, because as soon as you end up there, you move immediately to jail. So if you do this, we will never accumulate a tally here, but we will accumulate a tally at the jail spot. Okay. There's also, as you play the game, you're rolling 2 dice at a time. So every now and then you'll roll doubles, which will be like 3-3. or 4-4, you know, two of the same number, if you do that, you will you get to go again. Okay, but there is a special rule that if you roll doubles 3 times in a row, you will go to jail. So if you roll so if you start at go and you roll 3-3, that's 6, and you end up here at Oriental Avenue. Okay, and then let's say you roll 4-4, that's an 8 more spots, 1 2 3 4 5 6 7 8 takes you right here to Virginia Avenue. Okay, so there we've rolled doubles twice. We've rolled 3-3, then we've rolled 4-4. So we would roll 3-3, we land at Oriental, we put a tally at Oriental saying we landed there. We roll 4-4, we go land at Virginia, we put a tally at Virginia. Let's say we roll 1-1, okay? We would not go to St. James Place, which is 2 spots away, but we would immediately go to jail, okay? So in that case, you would put a tally at Oriental, a tally at Virginia, go to jail, and then you'd put a tally at jail, okay? You would not go to St. James Place and put a tally there. You would, as soon as you rolled the 2 1s, you immediately go to jail. Is that okay? Yeah, question.
What is the tally keeping thing?
So in order, because the question that we ultimately want to answer is which spots get landed on more, which spots get landed on less. So here we're keeping kind of like a clipboard of marking off like which spots get landed on. So I'm keeping a tally somewhere else.
So we just kind of say, so if you land on it again, put another tally there.
Yeah, you'd put another tally, and we would keep saying, so you know, after hundreds of games, we might say we've landed on Boardwalk 87 times or something like that, you know. Okay, so that's that. There are also spots called community chest right here, and right here. There's 3 spots on the board that say community chest, and there's a deck. Okay, and if you land on that, you draw a card from the deck. There's 16 cards in the community chest deck. There's 3 spots for chance. They're the ones with the question marks, and in that case, you draw from the chance deck. Okay, and so what happens is you would land on the chance spot. You'd put a tally at chance. Or at least this is how I've interpreted the rules. Is you put a tally at chance. You draw from the deck, and sometimes these cards will say move to another spot. Okay, so it might say like move to Boardwalk, or move to the nearest railroad, or move to the nearest utility company. And there's 2 utility companies, electric company and waterworks. And anyway, so you would put a tally and say I landed at chance. Then you would move to the new spot and you'd put a tally there and say I've landed there also. Okay. The other cards in the chance deck will give you things like money or other things, charge you money, and so in those cases, you don't put another tally at chance. So it might be like win 2nd place in a beauty contest. Here's $10. In that case, you would just mark and say I landed at chance. You would draw the card, and then you don't move and you don't do anything else. Okay. Same thing goes with community chest. There are a card in community chest, and there's a card in chance that sends you to jail. So it might be you land on chance, you put a tally at chance, then you draw the card that says go to jail, then you end up in jail, and you put a tally in jail. Okay, now that you're in jail. Is that okay as far as community chest and chance goes? This is how I've interpreted. There is and as far as moving goes, you always move forward. Okay, so for example, let's say you're at this chance spot here at the bottom, and you draw the card and it says move to the nearest railroad. Okay, now when you look at the board, it looks like Reading Railroad's the nearest railroad, but the rule is you always move forward. Okay, there's only one card that sends you backwards. You're always moving forward. So in this case, the nearest railroad is Pennsylvania because you're moving forward. Does that make sense? Okay. Same thing over here. If you're here and it says move to the nearest railroad, you move forward and you go to Reading Railroad. Okay. Or it might say move to the nearest utility. The nearest utility in this case is the electric company. Okay. Over here, the nearest utility is Waterworks. Okay, because we're always moving forward as far as what the chance deck says. It says move to the nearest this or that. So that's what we do. Okay. And then jail. So there's this spot that says jail. If you just roll, like if you start at go and you roll 10, You land on jail, but you're over technically in just visiting. You're not in jail. And the next turn, you just keep moving forward. Oops. However, there are things like you click, if you land over here in this spot, you go into jail. Or if you roll doubles 3 times, you go in jail. Or if you draw the go to jail cards from chance or community chest, you end up in jail. And when you're in jail, you can only get out either because you roll doubles or you pay a $50 fine. Okay? So, and people have discussed strategies for Monopoly as far as whether you want to stay in jail or get out of jail. Okay? The rules in Monopoly say you can stay in jail up to 3 turns. Okay? On your 3rd turn in jail, you have to leave jail. Okay? Or if you roll doubles, you have to leave jail. Depending on, when you're playing, the general strategy is, while there's lots of properties still to be purchased, you want to get out of jail immediately. And when all the game spots have been purchased, you want to stay in jail. Okay? That's generally the consensus. However, just for simplicity, we're going to say we're going to stay in jail as long as we can. Okay? And it sounds silly, but in this game, staying in jail can actually be beneficial. And so we will stay in jail and we will only get out of jail if it's our 3rd turn in jail or we roll doubles. Okay? So you can stay up to 3 turns in jail. So in our thing, we'll stay 3 turns in jail, but if you roll doubles, you get out of jail. So that's jail. And the funny thing is, though, is that if you're in jail and you roll doubles and you get out of jail, you don't go again. So generally when you roll doubles, you get to take another turn. Unless you roll doubles when you're in jail, then you don't go again. You just move that spot and you stop. Okay? So let's say you're in jail and you roll 2 4s. So that's 8. You'd go 1, 2, 3, 4, 5, 6, 7, 8. You end up at Tennessee. And then you end your turn. You don't go again, but you get out of jail. Okay, is that all right as far as what's going? Okay, and so again, I have the official rules posted. You can click this link, and you can also watch videos on the rules and things like that. So as far as the simulation goes, I've written some getting started code and I've posted it for you on CCLE. Okay, and so I thought I would spend some time going through the code here because I think it provides a fairly good framework for how this simulation should be done. Okay, and I'm doing this because when I assigned the assignment before, I got back these very complicated solutions, and I'm not entirely sure if they completely worked or not. So I'll tell you, my solution for this is about 250 lines in code. Okay? But I've gotten, and that's not a challenge or a goal for you guys to achieve, but it's a guideline saying, it doesn't have to be crazy complicated because I definitely got answers in the past that were closer to 1,000 lines of code that I would say did not do any better of a job, possibly even did a worse job. And generally when you have longer code, it takes longer to run. Okay, and so when you run 1,000 games, people were saying it took their computer an hour to run 1,000 games. It should not take an hour to simulate 1,000 games. Okay, I simulated 1,000 games or something. It took maybe 5 or 6 minutes on my computer to do. So if you're writing thousands of lines of code and it's taking an hour to simulate thousands of games or longer, something probably is not quite right with your code. So I strongly suggest that you write a reference class object to keep track for this game. Okay, and a reference class object, if you remember back to our week on object-oriented programming, is a mutable class, meaning you can modify the values in place. Okay, and it's useful for keeping track of our player because the statuses of our player will change over time. Okay, so anyway, if you open up that getting started example that I posted on CCLE, I've programmed the game board and chance deck and community deck for you. Okay, so these are data frames for us, and you can just look at game board, and it just has the index of the spaces 1 through 40. There's 40 spaces, and it gives us the title of each of these spaces. Okay, same with the chance deck. Okay, we have advanced to go and all of this stuff. Okay, and I've also arranged the chance deck so that the first 9 cards are the ones that involve movement. Okay, and the remaining ones don't. So these ones leave you in spot. And don't worry about get out of jail free. We're not going to program anything like that. We're worrying just about board movement. So if you draw any of these things, so you're probably going to want to write a chance deck function, and in there you're going to do like sample 1 through 15, comma 1, to just draw one number between 1 through 15 at random here. I've provided 2 functions for you for dice. Okay, and so here, this function dice samples 1 through 6 with replacement twice. And when you run dice, this function for dice, it will return the faces. If the faces are the same, okay, let's see if I can pull one. So in this case, if it returns 2, 2, it's going to say doubles true. Okay, and it will also return movement. So dices will return a list of the faces, whether it's doubles or not, and the movement. Yes?
In the code for that, what's verbose equals?
Yeah, so what is verbose? Okay, so verbose is an option that I recommend using in your code to help you debug and program. Okay, and so generally, as you're running the code, you're probably going to do something like roll, and inside roll, we're going to take the results of dice, something like this. Okay, and when you do this, you can get roll movement and figure out what you rolled. Okay, roll, and then you say, okay, you roll the dice, and then you can ask the movement. Now, notice that every time I run roll dice, nothing gets printed out on the screen, so I can't really see what's happening. Okay, now if I set dice, if I turn roll dice and do verbose equals true, or I can, because there's only one argument, I can just do dice for verbose true. Here, every time I do the assignment, it prints out something onto the screen that says this is what you rolled. Okay, and so it's the same function, but every time it's being called, it prints out a little bit of stuff that's helpful for us as we're programming. Okay, so the verbose option just says keep telling me what it is that you've done, so that as I'm programming, I can see if this is behaving the way I want it to behave without needing to enter debug mode. Okay, so we can do that. So that's the dice function. I'm also providing a reference class called dice, and this will allow you to program manual dice. Okay, so as you're doing your thing, sometimes you want to see, does my function work when I roll 3 doubles in a row? Will that send me to jail? Okay, you might have something written, but you want to test it out. Okay, it's going to be very frustrating to test it out with regular dice because it's going to be random, and you're going to have to keep waiting for those one in that rare opportunities or rare times where you rolled three doubles in a row. So when you do the manual dice, you can force the computer and say, I want you to roll a 4-4, a 4-4, and a 4-4, and you can test to see if your doubles functionality is working there. Okay, so you can do that. Okay, so I'm not going to get into the details here. I'll just show you how this works later on, and basically when you set the manual dice, you get back a similar thing, a list of faces, doubles, and movement, but you can actually set what the dice will be. Okay, so here this is kind of, I think this is going to be the heart of I think at the end of the day, you're probably going to want to have, there's going to be a few main functions. Okay, one is going to be your player reference class. Okay, in your player reference class, you'll have a bunch of methods that do all of these things. Okay, And then you'll also have the take turn function, okay? And this will list out all the things that are supposed to happen when a player takes a turn. Okay, all the things that you have to think about when a player takes a turn. Okay, and then you'll have probably some side functions like what do you do when you draw from the chance deck? What do you do when you draw from the community chest deck? Okay, it doesn't have to get too much more complicated than that. This is the player reference class, and I want to kind of just go through it. This is a very basic form that you will definitely need to expand upon this. Okay. So as far as this player reference class goes, I'm keeping track of really just one thing, the position that the player is on the board, okay, where the player is on the board, okay, and I'm also doing verbose true or false, which is a way to print out the useful stuff that I want or not, okay. Other things that you'll probably want to keep track of as a player, maybe you want to write these things down, is how many times you've rolled doubles, because that's going to keep counting, right? It's going to go from doubles 1, doubles 2. On the third doubles, you go to jail. So you'll want to keep track of how many times you've rolled doubles. You'll want to keep track of whether you are in jail or not, okay? If you're in jail, the way the thing works is different, okay? And you'll also want to keep track of whether how many turns you've been in jail, okay? Because if you if you're in jail, you can stay up to 3 turns in jail, and so you'll want to keep track of how many turns you've been in jail. And there might be other fields that you want to include, okay? Like maybe whether you rolled doubles or not during this turn or something like that. All of these things. And then here I've given you 2 methods, okay? One is move n spaces, and one is go to space n, okay? These are just 2 methods. There's other methods that you'll probably want to program or add to your player reference class. And so I think what's helpful is to think about just imagine yourself playing a game of Monopoly and writing down all of the things that you have to think and keep track of during your turn. Okay, so think about what's actually happening when you're playing the game, and the things that you're thinking about when you say, oh, I rolled this means this, and all of that. So anyway, the methods here are move n and go to space n. Okay, so as far as move n goes, really all it does is takes the current position and adds n to it. So if you're at position 3 and you rolled a 7, you're going to move 7 spots and end up at position 10. That's really all it does, okay? And over here, if you reach the end of the board, because the board is a circle, if you go past space 40, you subtract 40 from it to say, like if you start at boardwalk and you roll a 7, you're not at 47, but you land up at space 7, okay? And then here I just have options for if verbose is true, right? If verbose is true, then it's going to print out these kind of useful messages for us so that we can kind of see what's going on. So it's going to say players at position this, player's going to move n spots, player's now at this position, okay? And you probably, you can change this to something so that it's, more useful to you or something like that, okay? And go to space n. This will be used when, like if you draw the chance deck and it says go to boardwalk space 40, you're going to just say go to space 40, right? So now you just change your position to what n is, okay? And because this is a reference class, we're using the super assignment to change the values inside this player environment, okay? So this is the reference class. And I'm going to just define a new player by saying a new player is going to start at position 1, and here we're going to have verbose equals true. So this is player 1. And so player 1, I can ask what is player 1. Its position is verbose and true, so I can do player 1, and I can do one of the methods, move n, we'll say player 1 is going to move 7 spaces, okay? And because it's verbose is true, it's going to say player's at 1, player moves 7, player now at 8. Okay, So that's what it does. And if I do, we're gonna roll 4, okay? It keeps track of this. Player's at 8, player moves 4, player's now at 12, okay? So this is what's happening when I have this, okay? I can create player 2. Player 2, I can do player 2, and I do move. Maybe player 2 rolls a 12, okay? So player starts at 1, moves 12, and is now at 13, okay? Maybe player 2 moves 12 again, and is at 13, player moves 12, player is now at 25. So that's what we have. That's what we have here, okay? We want to keep track of where people have landed, so I'm going to create a new reference class called tracking, and this is basically tracking just has one field in it, and it's a numeric vector, okay? And it's going to be a numeric vector of length 40, and it's going to just be used to keep track of where people have landed on those 40 spots, okay? And keep the tracking has only one value or one method called increase count, and all we're going to do is we're going to take the tally in that numeric vector, okay? So the numeric vector is called tally. We're going to take that numeric vector in spot n, and we're going to add 1 to it. That's all we're going to do. So this is our tracking thing, and so space tracking, if I look at space tracking, this is the result of our new tracking reference class. It's just this vector of 40 things, and I can do space tracking. I'm going to do increase count, and we're going to say we're going to increase the count at spot 5, okay? So now if I look at space tracking, we can see spot 5, the tally there has increased by 1, okay? And if later on, if we land at spot 5 again, okay, we can see space tracking now has a 2 at that, okay? And there's 40 values, 1 for each spot. Okay, and so here is the most basic turn, okay, without any of the other rules applied to Monopoly. Basically, in our basic turn, we roll the dice, we take that movement, we move n spots, and then after we move n spots, we're going to increase the count in our tracking thing, okay? So what we do, so take turn is a function of the player and the tracking thing. So what we do is we say, whatever player you give us, this is going to be of reference class player, we're going to do move n, and we're going to take, remember roll returns a list, and what we want is the movement in the list. So we're going to say take the movement in the list, and then we're going to apply the method move n for the player. Okay, after we do that, then we're going to take our tracking object, okay, in this case is space tracking, and we're going to increase the count in the field player position. Does that make sense? Okay, so here so this is a very basic thing, and you can expand on this, okay? But it doesn't, so just take advantage of the reference class fields that we're using and the methods. You don't have to do these complicated things that I've seen people try to do. So here it's just taking a turn. It's a function of the player and tracking, okay? So let's test one of these out. Let me just reset my space tracking, reset player 1, player 2. These are new players starting at space 1, okay? So player 1 is this, space tracking is completely empty, okay? So here I'm going to just set the seed 1. So when I do player 1 and do space, okay, I've rolled a 5, okay, and I'm now at spot 6. I'll do the same thing with player 2. Player 2 rolls a 10, is now at spot 11. And we can take a look at space tracking, and we can see indeed it updated the position at spot 6, and it updated this position at spot 11. Okay? And if we ask what's up with player 1, player 1's current position is at spot 6. Okay? So, and with this, you can run simulations very quickly. Okay? See here, I'm going to just do, maybe I'll just do simulate 2 games here, okay? So here I want to show you I've got a loop inside a loop, okay? And so in the inner loop, all I'm doing is we're gonna just basically do this. If player 1 is verbose, we're gonna print out take player 1 turn, and then we do take turn for player 1. And if player 2 is verbose, we'll do player 2 turn, and we'll do take turn for player 2. Okay, that's basically it. Okay, and in the game, we're going to do this 150 times. Okay, so we're just going to say a game lasts 150 turns, and that just means player 1 goes, then player 2 goes, player 1 goes, player 2 goes. This happens 150 times. So so we do that. Okay. After that finishes running, okay, the loop on the outer side is we're going to just run 2 games, okay? And that does, with each game, we're going to print out new game, and we reset our players. We say player 1's a new player starting at position 1, and player 2's a new player starting at position 1, okay? Here, let me just do verbose is true, and verbose is true, okay? So here I'm going to run a loop inside a loop. We'll reset space tracking, and you'll see it goes very quickly, okay? And it's going to just print out a whole bunch of stuff. It goes, okay, and it's done. So, and we can see, you know, let me just scroll back, and it has completely filled my screen buffer here, but let me see. Somewhere along the way, it'll show where the new turn begins, or new game. Okay, so here, you know, this is new game 2. It says player 1 turn, player's at 1, player moves 11, player's now at 12. Player 2's turn, player at 1, position moves 6, player now at 7, player 1 turn again, player's at 12, player moves 12, player's now at 24. Things like that, okay? And it just cycles through, okay, and it keeps track of all of these things, and all of this is kept track in terms of space tracking, right? We can see the vector for the tallies. All of these things have been incremented as the game went on, okay? And to see the results, we can just bind the game board, column bind the game board with the tally, okay? And we can print out our results data frame. Okay, and we have this. And then here I wanted to add kind of the relative frequencies, okay? And we can see how many turns have happened, 600, right? Because 150 for player 1, 150 for player 2, and we did 2 games. So, and with this, you know, you can run through a whole bunch of simulations very quickly. I can do 100 games. I'm going to turn off verbose. I'm going to do verbose as false now, okay? So it's not going to print out all of this stuff. And so this here, I'm going to do 100 games. Let me just reset space tracking here. And so now it's just running through games, you know, 1 through 100. And now it's done. And we can take the results of space tracking. Okay, this is the vector of all of our things. And we can take a look. And you know, this is 30,000 turns, and we can even create like a bar plot. And at this point, because I've implemented none of the rules, our distribution should be uniform, right, as far as where the spaces have landed. So I can do bar plot of space tracking tally. Whoops. Okay, and we can see indeed it does look fairly uniform for all 40 spaces, okay? And that's after 100 games of 150 turns each, okay? So, you know, I would encourage you to try to write your loop so that, or your code, so that really to simulate the game, all you have to do is take turn player 1, take turn player 2, okay? You don't really want to make it more complicated than that. I would say try to think of your methods, think of all of the things so that, and put them all into your take turn function so that when you run take turn, it'll operate, okay? Here's a hint when you do the doubles, because when you run doubles, when you roll doubles, you're essentially taking another turn. You can do kind of a recursive thing, and you can call take turn from inside take turn, okay? And that There's no need for making it any more complicated than that. Okay, I want to show you using manual dice here, okay? So with manual dice, you're going to create a vector of the values you want to roll. So here, this means I'm going to roll a 6-4, then I'm going to roll a 5-3, then I'm going to roll a 3-5, and then I'm going to roll a 6-2, things like that, okay? So these are manual dice that I'm rolling. And to use the manual dice, I'm going to rename. So this is using the reference class dice, and I'm going to create a new function. And all this is going to do is it's going to just do take this set dice reference object and use the method roll. Okay. And so in this case, I'm going to set my dice. I'm going to create my dice function here, and I'll create a space tracking object. Okay. And I'm going to create a new player here. And so as far as this goes, okay, each turn I'm just going to do take turn, player 1, and space tracking. And because the take turn uses the dice function, and I've reassigned the dice function to use my reference class dice, you can see what's going to happen. It's going to use the dice rolls that I feed it here. Okay, so I'm going to take 20 turns using this, and you can see what has happened is that it's using the dice rolls that I've specified here. So it rolls a 6-4, and it moves accordingly. And then it goes to the next two. It rolls a 5-3 and it moves accordingly. Then a 3-5 and moves accordingly. Then a 6-2, and then a 5-4, and so on and so forth. Okay, this is useful because again, sometimes you want to see like what happens when it lands on chance. Does it do what it's supposed to do? And you can test that out. Does it, do I get out of jail when I roll doubles? Okay, you can manually set the doubles in your dice. So that happens rather than you're being at the whim of the random number generator. Okay, and what I've done, and this may or may not be as helpful for you, is on CCLE I've posted what will happen for these 20 turns. So I've given you some set dice here, and this shows you what happens. So if you roll the 6-4, and this is kind of my very verbose output, okay? You start at 1, go, you move 10, you're now at 11 at jail, okay? But you're not in jail, so now you roll 5-3, you move 8, and you're at Tennessee, so on and so forth. And you can just see kind of how the game is moving, okay? And I'm also marking where I'm putting tallies, right? So we end our turn on jail, we put a tally at jail. We end our turn at Tennessee Avenue, we put a tally at Tennessee Avenue. We end at Atlantic Avenue, we put a tally there, okay? So here's where I start testing out my different functions. So here I rolled, on turn 8, we rolled doubles, okay? Now our double count is now 1, so I put this kind of in my verbose thing. Okay, so player moves this, we end at Illinois Avenue, tally at 25 Illinois Avenue, okay? We rolled doubles, so we're taking another turn. Here we rolled 4-4, okay, our doubles count is now 2. We move accordingly, we tally, then we take another turn, and in this case I rolled 2-2, okay? The doubles count is now 3, so we go to jail, okay? And we don't add any tallies for anywhere else other than taking a tally at jail. So it doesn't, we didn't even trigger the movement method there, okay? And you can see what happens when we're in jail, okay? We roll a 4-3, so we stay in jail, we put a tally at jail. We roll a 4-4, which means we've rolled doubles, we're gonna get out of jail, and we move accordingly. Yes?
If you're in jail and you don't get out on turn 9, you put another tally on jail. So you
Yes,
tally
yeah.
jail 3 times.
Yeah, you keep putting tallies at jail. So over here, so here's one where we go to jail, okay? We put a tally at jail. This is our going to be our first turn in jail, okay? And we stay in jail. This is our second turn in jail, we stay in jail. And over here, this is our third turn in jail. And because it's our third turn in jail, we're going to get out of jail even though I rolled a 5-4, okay? And we move accordingly, and we tally things accordingly. So this So you can kind of study, I guess, this output showing you exactly what's supposed to happen in each of these scenarios, and you can kind of test out if your functions are working accordingly, and things of that nature. Okay, so these were contrived, and this is the tally thing that I've generated at the end. So I do strongly encourage you to use the reference class. I know it might feel a little awkward and cumbersome in the beginning to try to think of the reference class, but try to break down all of these things as far as different methods that you can program, and I think that will make your life easier in the long run as far as the programming goes here. Okay, so we'll end here. I have office hours, so you can come by and ask questions, and we'll see you guys. So good luck.